Okay, let's get started. Welcome everybody at a new Bytes of Innovation webinar. Bytes of Innovation is a webinar that's powered by SecMed, which is a company that provides medical imaging data for research purposes. At Bytes of Innovation, we invite key opinion leaders to talk about the future of healthcare. Typically, the concept is we have a fireside chat like today, or we have a presentation by the speaker. The webinar is co-hosted by Dr. Aline Lutz, who is the Vice President of Real-World Evidence and Clinical Insights at SecMed, and it's co-hosted by myself. I'm Martin Willemink, co-founder and Chief Scientific Officer at SecMed. All the people in the audience, make sure to put your questions in the chat box so that we can discuss those during the fireside chat. And for today, I am very proud to announce that we have Dr. Erik Duhaime amongst us. He is the CEO and co-founder of Centaur Labs. So in his career, Erik has spent a lot of time to tackle one of the hardest and also one of the most underestimated problems in AI, and that is how to provide data quality at scale. So he's built Centaur Labs, where they built a platform that blends human expertise with AI-driven annotations to help teams move forward from raw data to production-ready data sets. And all of that while meeting high standards like HIPAA and SOC 2. So Erik has an academic background where he also did a PhD at MIT, and during his PhD he actually studied how humans and machines can work together to make better decisions. So it's really great to have Erik with us, and we'll learn much more about what he and the Centaur Labs team are doing. So first of all, welcome to join Bytes of Innovation today, Erik. Let's start with, during your PhD research, you really focused on the collaboration between humans and machines, and you are focusing that on labeling. Image labeling mostly, but also text labeling. How did you get to the labeling component? What was it that attracted you there?
Yeah, I mean, where I started was just this thought of how do you make the best decision possible? How do you analyze a piece of data or make a decision about the world or make a prediction about the world? So, today prediction markets are really in vogue. That was something I was very interested in 10 years ago before most people had heard of prediction markets, because if you're trying to make a decision about the world or predict, what's Apple stock's earnings going to be like, whatever it is, prediction markets were actually the state of the art of how do you make the best decision possible? Well, you get a bunch of people to put their money where their mouth is. And the reason prediction markets are interesting is because, rather than just trusting an individual expert, some expert you can invite onto a news channel or something, you're leveraging the collective intelligence of many people around the world. So I was interested in, well, how do you leverage the collective intelligence of many people and or algorithms together around the world to make the best decision possible about something impactful, like whether an image shows signs of cancer in, say, a skin lesion. So I started thinking, how do you make the best diagnosis? Or how do you solve any impactful problem? And then ended up in this space of labeling for companies building AI, and specifically in healthcare, because it seemed like one of the most important problems. And then, ended up in specifically labeling instead of just diagnosis. Frankly, it's one of the more scalable challenges. In order to build one of these AI models, you need thousands or sometimes millions or tens of millions of images accurately labeled. And so it was just, since we developed a really scalable, accurate approach for doing this, it seemed like one of the best places to apply this technology that we had. Now, I do have dreams one day of leveraging what we're doing for actual diagnosis, but I also don't want to take a radiologist or a doctor or whoever out of the loop for a very long time.
Yeah, it's kind of interesting how you mentioned the scalability here, because we actually initially, the name SecMed is because we wanted to segment images and label images, and we realized, okay, this is a very complex problem. Also, there are already companies like Centaur Labs doing this, so maybe we should focus on something else. But because if you think about it, having experts doing labeling is not necessarily scalable, but you actually make it scalable by also make it possible to do non-expert labeling. That's kind of exciting, I think.
Yeah, there's a couple ways that we make it scalable. One thing we actually made annotation a competitive sport. So you've got, all these doctors on our platform that are all competing with each other to prove that they're the best at doing something like draw around images. And doctors are very competitive people, and we all know, even if you're not a competitive person, and you're not a doctor, we all get motivated by games and leaderboards and things like that. Sometimes people will see me give a demo of our platform and they'll say, "What? Why are all these experts doing this for so little money?" And I say, like, well, no one pays me to play chess on my phone, and I really care about beating that random person halfway across the world, and no one's paying me money to do that. So gamification and aligning incentives goes a long way. And then the other thing that we do, you alluded to, is you could call it non-expert labeling or semi-expert labeling. What I really say it's more like is identifying people that are experts at the specific task you care about, that you wouldn't necessarily think are experts based on, say, their credential or how they performed in an interview. So one story I like is we were doing labeling for a group at Mass General Hospital where we were labeling EEGs. And the guy that we were working with, he's the president of this academic consortium of epileptologists. And it was for their annual conference. He wanted us to have this competition where all the experts would compete. And he even made this custom T-shirt that said, like, "You're the best at EEGs" or something. And he was going to give away this custom T-shirt at the conference to the person that was the best. But he let us leave it open to our broader global network, which included folks like medical students. And to his surprise, of the 50 or so specialist epileptologists with 10 years experience at this conference, the best one came in 9th place. And he said, "These are all the world experts. How did this happen?" And so we interviewed some of the guys that won. And there were these two guys in particular who were medical students in Ghana. And we said, "How on earth did you beat these 50 experts?" And they said, "Well, we're 5th-year medical students. We're going into neurology. So we were frustrated that we were bad at this task. So we skipped a bunch of classes and watched YouTube videos and read papers. But most importantly, we looked at thousands and thousands of cases at this specific task, which was look at an EEG and classify like 8 different seizure-like patterns." And so by the end of a couple of weeks of doing that nonstop, like, are they the world's best neurologists? No, but I'd say that they were certainly experts at classifying EEGs for seizure-like patterns. So, you might not think, oh, this medical student is the expert I want to hire, but actually those two guys were better than the world experts at this task because they had been laser focused on training themselves and improving their skills at this very, very narrow thing that the researchers wanted. So again, I'd say it's less about having non-experts do the work and more about finding the experts who you might not think based on their credential are actually experts at that task.
Yeah, that's exciting and interesting, especially since the less experts who actually are experts at this specific task, but probably charge less per hour than the world-renowned EEG expert or something like that. So
yeah, and that's part of what makes it scalable. And then for those folks, medical students, part of how I started the gamified mobile app that we have where people do annotation called Diagnose Us. It's one word, diagnosis, but with a U instead of an I as the second to last letter. Part of why I started is I saw my wife going through medical school at the time, and I don't pay for a mobile app if it's more than free most of the time, or if it's more than $1 or $2. But medical students are paying hundreds of dollars for apps that basically just help them train and do practice questions. They're really motivated to get good at things like reading EKGs or EEGs or whatever it is. And so, not only do they not cost as much if you hire, say, the med student to do this task, but a lot of them do it for fun and for educational benefits. They're getting a free platform where they can train and improve their skills. So, like, to take those guys as an example, they were motivated by the fact that they were going into neurology. This mattered for their career, and they weren't good at the task. So they used this to train themselves up.
Yeah, that's a very, very interesting story, Erik. And it's not just nice to see that people really get motivated by this task. So in practice, how do you blend experts and community labelers in this work? Is there an adjudication system, or maybe a statistical analysis on performance and how the task gets the same results over time, or things like that?
Yeah, so we have an engine on our back end that I'd call it statistical in nature, where we combine the votes of multiple people and/or algorithms to drive quality further. So, sometimes I liken the approach to putting together the optimal trivia team. If you want to answer a bunch of trivia questions, you probably want more than one person, and you don't necessarily want, let's say, 5 people that are all the same. Instead, you want someone who's really good at, sports trivia, and someone who's really good at history trivia. So in the same way, doing something like analyzing, say, a skin lesion for cancer, some people are better at finding melanoma. Some people are better at classifying basal cells. Some people are better at classifying cancer on dark skin versus light skin. And people don't necessarily know this about themselves. So if you measure their skills and expertise really narrowly, you can then combine votes more accurately. At the simplest level, the way to think about what we do is we look at the inter-rater agreement of people and the past performance of people at that task. So we'll set decision rules where we say, don't trust the work of anybody unless they've seen a number of cases where we knew the answer and that they were performing very well on those cases. This is not just a test that they pass once. They need to keep passing this test. So we'll keep sprinkling in this work where we actually know the answer and we're testing them. So then we'll throw the work out of people that aren't doing a good job, and then we'll combine the work of people that are doing a good job. So that second piece is looking at the inter-rater agreement. So let's say the first 3 people at a task all agree. They're all very good at this task of classifying skin cancer, and they all agree that this is cancer, it's melanoma. We might then say, well, based on how these people vote on cases where we knew the answer, we know with very high confidence that if all 3 of them say this is melanoma, then it's melanoma. But if they disagree with each other, it's 2 votes to 1 or something, we're then automatically going to escalate that case and get additional votes on it. So maybe we'll ask, 6 people until it's 5 votes to 1, and then we'll stop. But if it's 4 votes to 2, maybe we'll keep going. So there's this dynamic solicitation rule where we'll escalate a case based on having low inter-rater agreement among the people that are the best at that task. And that's much more productive and much more accurate than if you just ask one person. There's always noise in any one person's vote. And it's also much more efficient than if you set some fixed rule, like we're just going to ask, 5 people on every single question. You would rather ask 7 people on hard questions and 3 people on easy questions.
Very cool. So you use the disagreement as a signal that case needs to be escalated.
Exactly. When we send data back to our clients, we don't only send them what we think the answer is, what that annotation is. We give them this estimate of confidence and uncertainty. So on all labels that we have, it's not just one human that does it. It's a combination of people. And we use that to say which cases are controversial or which ones are straightforward. That then is really useful to AI developers because they can then look at the controversial cases and say optimize their algorithm for those. Those are the ones that matter the most. Or also when we work with the client early on, we'll discover the controversial cases are controversial because something isn't clear about what the AI developer is trying to accomplish. And that might be something that really needs to be refined up front. So there's a different standard for how big a lung nodule is supposed to be, whether you're in the EU or the US, for instance. So if a client says, I'm trying to build a model in healthcare that will identify lung nodules, you really want to figure out early on, there's this discrepancy for small nodules. Maybe that's because the standard for what nodules you're targeting. And then you need to say, how big do you want nodules to be for your algorithm to classify it that way? And then that'll let us train the annotators. So figuring out what's controversial early on is really valuable, provides valuable insights for when you're building your model, rather than say annotating a bunch of data and then realizing at the end that there's something about your AI model that doesn't work the way you want. One of my co-founders was at Cruise, the self-driving car company, in the early days. He was their first engineering manager in charge of annotation. He told me a story about they annotated millions and millions of images and then realized that ambulances and other emergency vehicles needed to be, indicated in a different way. And so they then needed to go back and redraw or reclassify all these things that they'd done because they hadn't identified that early on in the process.
That's crazy. So I think the idea of expert labeling is so entrenched in AI training and any data collection protocol So how do you see the market, and how is the acceptance of your proposition, let's say 5 years ago to now? Has it changed, or what? How do you think the market is going for expert versus community laborers?
Yeah, I'd say 5 years ago, most of the focus was on, hire a bunch of relatively unskilled generalist annotators in a developing country for as cheap as possible to do things like draw around cars. And that's definitely shifted as AI models have gotten better. The demand now is for doctors, lawyers, PhDs, subject matter experts. I think our take on the current market is that the AI developers have realized that the models are better, and so they need experts to do high quality annotation. I do think that today they're in the process of realizing that just hiring someone because they're an expert does not mean you're going to get the best quality necessarily. So we see time and time again, you hire the world key opinion leader in radiology for a certain thing, and it's someone with 30 or 40 years experience, but they don't actually do a good job carefully drawing around each lesion, and it's actually the resident or the fellow who's really motivated and who really cares about this work and who's fresh off their training. They're often the one that's doing better. So I think you'll continue to see in the next couple of years, a shift where people are thinking not just about accomplishing high quality annotation by hiring someone with the fanciest pedigree, but where they're thinking about quality in a more data-driven way of who's actually producing the highest quality work for what is, sometimes tedious work that requires high attention to detail and high skill, high pattern recognition.
So that's an interesting process, Erik. When you think about quality and about your platform where there's millions of annotations done like on a weekly basis, it becomes really hard to get the quality good when it's such a mass production. How do you make sure that you keep the quality in place with so many annotations being done?
Yeah, that's part of why we have this gamified or competitive model where we're continually tracking the annotators. So, if you think about the status quo is it might be hire someone because they, have a certain degree or they did their fellowship in a certain area and they did well on some interview. Then you train them up and have them pass a test. And then you sort of trust them. And then, maybe a month later, you have your internal chief medical officer, whoever, review the work and realize there's some mistakes there. And then you sort of talk to them and retrain them, and you don't know how to go back and figure out, of all the work they did, what's good quality, what's bad quality, where did they not understand how big the lesion was supposed to be according to our protocol. So that's why we overinvest in the amount that we test people on a continual basis. On our platform, this varies based on the task, but let's say anywhere between 10 and 50% of the time they're doing work, we're actually testing them. So instead of test them and then purely extract work out of them, we're embedding the quality control into their workflow on a continual basis. So we don't need a manager to review millions of labels because the system will automatically throw out the votes of people if their trailing average accuracy goes down. So we'll identify, oh, someone's gotten lazy, or maybe someone's doing annotation in the Uber home from the bar and they're not doing as well. We don't need a manager to spot check that and then throw that work out. That's automatically getting thrown out because their trailing average score at the task has gone down because we're measuring their performance on such a frequent basis. So those two guys in Ghana that I was saying that are the world experts at tagging these EEGs, the first week or so when they were doing their work, they weren't especially good. They were training up. We didn't need to manually train them. We didn't need to review all their work and give them feedback and throw them out. They were getting that automatically because we were mixing in these test questions on a continual basis. And then once their performance improved, the system automatically identified, oh, now their trailing average accuracy is actually a standard deviation or two above everybody else, all these other experts. So now we're going to start counting their votes.
Yeah, that's very interesting. Yeah, and it's, I guess, important to not kick them out right away when you see, oh, they're not performing very well now, but let them train a little bit, get to that level, and then actually include them. Yeah.
Yeah, there's a few different workflows there where we might, give people some prizes or incentives early on, even if we're not sure they're good yet. Or, if you think about another way to think about this it would be forget the truly global open, forget the med students. Just think of the problem of, let's say I know that I want to hire radiologists for a task. And I can go overseas. There's probably as many, if not more, good radiologists in Asia as in the United States. And yet the instinct of folks in America is to hire the US board certified radiologist because there's this certain bar of quality. And if you go overseas, there's much more mixed quality. It might be a market for lemons where the best ones have some other job and you end up hiring the bad ones. Well, that must be really frustrating to be, the best radiologist in India who's then getting paid less than the guy in America to do the same annotation work. But on our platform, we're going to figure out that person is really, really good and count their votes. And we sort of solve that market for lemons problem. So, that model, we might start by hire 100 radiologists and pay them all a good hourly rate for the first few hours. But then we're only going to retain the top ones. And the bottom ones, we might say, look, if you want to keep working, that's fine, but you're ranked really low. So you can keep training up and your rate might go up. But right now we're just going to pay people's rates, not based on their geography in this setting. We're going to pay their rates based on their data-driven performance.
Yeah, interesting. So one other thing I saw you guys developed is the quality playground. I actually played around with it a little bit. It's pretty cool. Can you explain a little bit to the audience what it is and what you can do with it?
Yeah, so we took a data set that we've worked on and where we've had, multiple different types of annotators. So we'd had LLMs as judges try to annotate this data. We had many different people from our global network. So think of the med student types, and then we had experts. And so the experts cost a different rate. They cost much more than the big global network. And even among the experts, some cost a little more than others. And then the LLMs cost something, but virtually nothing. And so we just asked, if you've got a fixed budget and you're trying to optimize accuracy, what is the right strategy? Should you hire one expert to do the whole thing, or maybe you can pay 1.5 experts, one expert to do everything and then one person to do half of it? Should you pay the community of, say, med students and LLMs, and maybe one expert does 1 in every 10 questions? How do you optimize your budget and get the best accuracy possible? So the playground lets you toggle different values for these different strategies you might have on this real data set, and see what your accuracy would be for a given budget with that strategy of saying having all experts or all LLMs or whatever, and lets you see it's a really hard problem. But if you use data science to solve it and figure out what the optimal combination is, you can get significant gains in accuracy at the same budget, or you can get the same accuracy for a drastically reduced budget. So I'd encourage folks, I think it's linked on our website right now. If you go to centaur.ai, and you'll see this challenge to see if you can beat our process for how you would best optimize a budget by combining the votes of multiple different profiles of annotators for a given task.
That's very cool. I'll check it out. So let's talk about a bit about data sets and annotations for regulatory purposes. So what kind of audit is normally required, and what are the pitfalls or mistakes that people do, or wrong assumptions when looking for an annotation project for FDA submission, for instance?
Yeah, I think there's 2 areas where regulations matter a lot. So one is FDA submissions, but another that we've seen a lot of activity in is actually data de-identification in the health domain. So AI is driving, insatiable demand for new types of data and for new data sets. And, there's been solutions for de-identifying medical data so that AI developers can train on it for some time, but especially for text data. And none of these solutions are perfect. And now we see growing demand for areas like video data, audio data, dermatology images can be very difficult. And so having humans review and redact these images is a really large challenge. And we've realized that a lot of our clients, one of the things they're using us for is not actually, draw a box around the lung nodules in this CT scan, but actually draw around the tattoos and the eyeballs in this dermatology image so that we can get it, packaged into a data set that an AI developer can leverage while, respecting patient privacy. So that's one area we've seen growing, driven by new flavors of AI demand for these different modalities of data sets. And then the other area would be the FDA submissions that you were talking about. So for the FDA, typically what they want to see is they want you to do a reader study where you have multiple US board certified folks that are annotating the data set, or they're in other models, they're working with or without an AI model to see how that impacts their performance. But you need this ground truth data set in order to evaluate the performance of the model. Now, today, as I was saying, typically that's you get some number of US board certified radiologists who are quite expensive to do these reader studies. We have an offering, since we have the platform, we have the network of people, we do this for our clients, and it's much faster and much more affordable than if you go with a traditional CRO to do this work, because we're focused on the AI space, whereas the CROs have a history of being able to accommodate trials where patients are getting drugs. It's a much higher level of danger and concern for safety. And for AI studies,
sure.
it's really just, you need to show that this algorithm works and show that it's not gonna harm the performance. So there, you can move much faster by recruiting and managing a bunch of radiologists to do one of these studies. Now, I will say, I think the FDA's done a commendable job. I think they have a very difficult job in terms of regulating AI in healthcare. But one thing that I think would be important would be, rather than evaluating an AI algorithm on a small subset of, say, a few hundred studies, is what sometimes these look like, with maybe half a dozen radiologists, to give an example. It's constrained by size because it's so expensive to hire those folks. But we've shown that you can create a much larger data set that is even more accurate by leveraging the most skilled offshore annotators or the most skilled residents here. So what I think should be happening is not just you're having this small data set for the FDA reader study. I'd still advocate for that with a bunch of US board certified radiologists, but I'd also advocate for a larger set that's created through a process like ours to make sure that the algorithm is going to be more robust to different sorts of patient populations in different hospital settings and so on. And that is something that we see a lot of our most sophisticated clients. They care about that. They know that if they get through the FDA, but then their product doesn't work well, or they can't prove, okay, maybe it worked well at Stanford Hospital, but it doesn't work well at the community hospital across the street. They're aware of that. So they are testing their models more rigorously and more broadly than their FDA submissions.
You mentioned data de-identification. So I'm curious how you manage that. Well, when you work with SegWit data, you already receive the data that is fully de-identified as per safe harbor methods. But what are the common use cases where your team needs to handle de-identification?
Yeah, I think the most common are the sorts of the new types of data sets that I was saying are creating a lot of demand. So that would be, I think the hottest space is voice AI in health right now. There's several companies that have ambient scribes that listen to a patient-doctor conversation and try to generate summaries of those conversations and automate the notes, and then increasingly the billing and coding processes as well. But then also think of things like triaging patients calling into an emergent care setting, or even doctors writing summaries or doing dictations or other operational things. There's often sensitive data in there, but you need to customize these models. So that data is really valuable for model creation and refinement, but the data is sensitive, and you can't, an AI lab can't necessarily get the data if it has PHI. So I think that audio, video, and then other forms of images like dermatology images I mentioned is where we see the most demand. Whereas in, say, radiology images, there can always be something burned into it, but it's more standardized than, say, a dermatology image, especially areas where at-home care is mattering more. You never know what might be in the data. So, for instance, 8 Sleep has been a client of Centaur's, where you've got audio of people snoring and having sleep apnea and things like that, and you don't necessarily know what might be in the data set. So that's one area. And then with text data also, there are these approaches that have been around for a while, but they're pretty restrictive in terms of, they can remove a name, they can remove dates, they can do those things really well. but they aren't necessarily perfect at identifying, oh, well, given this context that was provided earlier in the conversation, now that they're saying this new thing about how they went to the store and it was a Stop and Shop on the corner, you might be able to figure out who they are. So we're also seeing clients that'll use a service like Amazon Comprehend that will help de-identify the data, but they'll need us to further refine it and make sure that it's good to go.
That's interesting. So how does that work? Because when you're de-identifying data, you're kind of, or at least the people that are de-identifying, especially if it's like in a large scale, non-experts that maybe there's no BAA. I don't know how all of that would work, but is it like you're sending PHI out to those people, right? How does that work from a legal?
Yeah, they are under BAA. So we have
Mhm.
we have what we call an audience of our data annotators that are under a business associate agreement with us. We also have other safeguards in place, like often data can't leave, say, the United States, unless it's de-identified. So we not only verify all these folks' identities who are under BAA, but we have geofencing, so we know that they're in the United States when they're accessing the data, because oftentimes the restrictions are such that even if you're a US-based doctor who's HIPAA trained, if you're on vacation in France, you're not allowed to look at that data. So we have technical safeguards against that.
Got it. That makes sense. So one other topic I think would be interesting to discuss is AI models and the performance of models, because of course you guys are the picks and the shovels, being able to develop the training data, same as us. Like we're providing the data, you guys are providing the annotations that's really needed to develop high quality data. There are models that are unsupervised. They can be trained without labeling or annotations. And there's also, to our case, like models that need less and less data for training purposes. What are your thoughts around those kind of training methods?
I think they're really powerful for different domains. So like pathology is a space where there's been some really exciting models that are primarily unsupervised, but folks that are working on those models still often need eval data sets. And if they're customizing them for specific use cases, they often need feedback on those models and they need to fine tune them further. So I think unsupervised approaches are really powerful, but I think that we're seeing, I might use a very large data set to train an unsupervised model, but that's sort of the starting point if I'm thinking about getting to a specific application or product that's going to work for a specific use case. So there you still need these very high quality, perhaps smaller data sets to do evaluation and to fine tune.
Yeah, makes sense. In terms of the model performance, there's kind of two camps. Some people say, well, you need like the latest and greatest model architecture to be able to get to a better model. And other people say, well, you need better quality data, larger data set, more heterogeneity, and those kind of things. I have a feeling on which camp you are, but can you elaborate a little bit and why, yeah, where you think the value is?
Yeah, I think the obsession with AGI is a little misplaced. I think the idea of the God model is an illusion. Um, what we're trying to do at the end of the day is solve problems in the real world. And I don't need a model that is the best at everything in the world. I need a model that's going to solve my problem. I need a model that's going to diagnose me based on a CT scan for lung cancer. And so, in order to figure out if a model's really good at that, what you need is really high quality data, and it might be a smaller focused model that's better at that task. If you think about, what intelligence even is, I think we anthropomorphize it a little too much. Intelligence is not it's not human language necessarily. It's not the things that we think matter. It's an animal or whatever, an AI's ability to solve problems that matter in its environment. And so if my environment is patient intake at a hospital setting, I don't care if that thing can also analyze a basketball game better than anything else in the world. I care if it can do the job the best. And so again, I think the idea of the AGI or super intelligence, a super intelligent model that can solve every problem is the wrong goal to have.
Yeah. And but for training these like larger models, or maybe even single task models, what do you think the value of the supervised component is there with having the annotations? Or do you think you can develop like more narrow specific models without annotations or labels?
I think that the supervised models and getting evaluations or feedback on models is most important when you're refining a model for a specific use case. So when you're building, the underlying, the foundation model, there, yeah, the analogy with building a brain is also, wrong in many ways, but it's helpful sometimes. You're building a brain that is really plastic, and it can go to school. It can go to undergrad, it can go to med school, or it can go to law school, et cetera. Now, where supervision is most important is the school there. The supervision is sending the brain to med school. And so there, you could have the person with the most raw potential intelligence in the world, and if you never teach them anything, they're never going to be a good doctor. And so, I think that's where it's most important. By the same token, of course, we wouldn't be here if you didn't have foundation models that were really, really powerful, if you didn't have compute that was more and more affordable, because you couldn't send a dog to med school either, even if you got the best medical school training in the world.
Yeah, makes sense. One thing, Erik, in the beginning, you mentioned that your long-term vision is not just applying your platform for like training or developing AI models, but actually applying it in a clinical setting where it would help with setting diagnosis. How do you see that with, there's a well-known development of machine learning AI models that are actually helping radiologists, maybe in some cases replacing radiologists for diagnostic purposes. Would that compete or with your platform, or how do you see that?
Yeah, the way that I think about the impact of these models in domains like, say, radiology is, I think people get wrong this idea of AI versus the doctor, like one replaces the other. I think in the last few years, as AI has taken off, most people have come around to like what Kurt Langlotz at Stanford says of, AI won't replace radiologists, but radiologists who use AI will replace those who don't. People are seeing AI as a tool that can help a radiologist or other doctor with their task. I think what people still miss is that a new technology like AI, often it doesn't necessarily replace work, but it does change how work is organized. So if you think of being a radiologist as like 100 different tasks that you need to complete, often we see with technological advancements, like if an AI comes along and it can do one of those 100, like maybe it doesn't actually get utilized because it just doesn't like really fit into the structure of how work gets done. Then once it can do 20 things, like right now, everyone sort of sees, oh my God, we need to figure out how to use this thing because there's so much potential value here. And you've got hospital CEOs figuring out how to embed AI into workflow and make workflows and make different investments here. But what happens then is not necessarily the radiologist does the 80 things they did before and now the AI does 20. It often breaks up a job into different sequences of tasks that maybe different actors, whether they're people or computers, are then completing those things. So I liken it more to like a digital assembly line of people and computers. So I think a lot of jobs right now, think of things that you think of as a discrete bundle of tasks that all are together are one discrete job. I think a lot of them are going to get broken up into something that looks more like a digital assembly line, like I was saying. And I mean, if you think about even making a car 120 years ago, if you made a car 120 years ago, you were a craftsperson and you did every step on your own. Then it became the assembly line, and you have people that are hyper specialized at different parts of that flow. And now you've increasingly got robots doing almost every step in that assembly line. So I think you're going to see the same thing happen to white collar jobs or expert jobs like being a radiologist, where you're going to have different elements of what they do now be done by an AI, but that also breaks up the work and means that there's other elements of what they do that might be done by a hyper specialized human who might be physically present or might be remote. That might be something like before an image goes to an AI model, there's just a human who's making sure that it is the right type of image taken on the right device to going to the right model. Then that might get sent to the radiologist, who's then reviewing the AI's output and providing a final judgment on the case. So I think that's the sort of change that you're going to see in the industry. And those are the sorts of areas where my vision really is I want to be the humans in the loop at all these different elements of this job as these tasks get broken up. And eventually more and more of them will get automated, but I don't think you're going to see doctors out of the job anytime soon. But I do think you're going to see a very rapid evolution of what the structure of these jobs is.
Yeah, that's an interesting perspective, and I do agree that it is naive or maybe premature to think of AI doing everything. So I'm curious. I was just checking out the quality playground where you can assemble experts and the collective intelligence and the LLM labeler. So it's super cool. So I'm curious, since your company started before LLMs were a thing out there in the market, so how did you incorporate LLM, and how was the transition for you and Centaur?
Yeah, the computer vision boom was definitely happening when we were starting. So it wasn't LLMs, but there was a lot of draw shapes on these radiology scans that was already in full swing. One way that we use LLMs is as a judge or as a rater. So you do see a lot of companies thinking, okay, getting evals on my data for my AI model is really expensive, so let me have an AI do it. I think that is really powerful, but I think it also can create biases, and you don't necessarily know which model is doing really well at this task. If you're trying to break new ground, if you need evals, it means that you don't think that a model off the shelf right now is good enough to solve your problem, yet you're using it to evaluate whether you're doing a good job. Again, it can work really well in certain settings, but I think companies that are depending almost entirely on LLM as a judge right now, or LLM as a rater, I think they're satisficing and not optimizing, and they're sort of just doing something that gets them somewhere, and it's not good enough for production. One thing that we do is we will use LLMs as annotators, but we won't trust them. We'll trust them just like we trust the average annotator, who we also don't trust until they prove in a data-driven way that they're good at a task. So I was playing around the other day. Diagnosing skin lesions for cancer is often, something I'd play around with. It might actually be what the quality playground's based on. I'm not sure what that data set was, but it's some of my PhD work that led to this. It's just a nice thing because there's a ground truth on a lot of these images, and there's publicly available data to play with. And I forget which, but of Gemini and ChatGPT and Claude, one of the models is extraordinarily good at the task. Maybe it was trained on some of this public data, and the other two are terrible. So in our system, we'll feed these skin lesions, the ones that we know the answers to a bunch of humans and to the AI models. But then we'll identify, oh, Gemini is really, really good at this task. It is worth, let's say, the same as a really skilled human. And then just like we do when we're using all humans, we won't just trust it because we want to do better than one skilled human. But maybe that'll enable us to have 2 humans and 1 AI model and basically treat it as one independent annotator. And then meanwhile, ChatGPT or Claude, if they're not good at the task, we're just going to throw their votes out, and we're going to learn, okay, it's not providing any value at evaluating for skin cancer at least, but maybe it will be for another domain.
Awesome. It sounds like you kind of have I don't know if you know the company LM Arena, like the large language model evaluation platform for diagnostic imaging in your hands here. But anyway, we're unfortunately hitting the end of the webinar. Time is going fast. I feel like we could probably chat for much longer, but we don't have that time. So I want to thank you, Erik. I think my main take-home message here is human in the loop is essential for data quality at scale. I think that's and there's a lot more learning points, and we'll share some learning points over time based on this webinar. But thank you very much, Erik. This was very insightful. Great to have you here. I also would like to thank Aline, my co-moderator, and Andrea, who the people here don't see, but she does a lot of the work behind the scenes. She's our marketing manager at SecMed. And of course, I want to thank the audience for attending. Our next Bytes of Innovation webinar will be on Tuesday, March 10th with Martina Eineseder. She is a radiologist at Hospital Italiano in Buenos Aires, and also consulting radiologist at SecMed. So really looking forward to see you all there. And thanks again, Erik, for joining us today.
Yeah, thanks, Martin, Aileen. It's a pleasure to be here.